Hello everyone. Today I'll discuss about Dijkstra's algorithm. This is one of the algorithm comes under greedy method, and this algorithm usually used to find the solution for single source shortest path problem. What actually single source shortest path problem means? Given a weighted connected graph G, and you have to find the shortest path from source vertex S to each of the other vertices. Single source shortest path means you have to find the shortest path from one vertex to remaining all other vertices. So that path must be shortest here. So let's see one example in general what actually it means. Assume that this is the one graph and I'll consider A as a source here. So now single source shortest path means what? From source A, that is source is A, from source A to remaining all vertices you have to find the path, and that path distance must be minimum. So now for example assume that I have to find the path from A to B. Now A is what? My source, and B is the destination. From A to B, what is the distance it is? It is 3. So that is what? A to B, your shortest path is 3 here. Next, same thing, I have to find the path from A to D here. So to get the path from A to D, see here one path is there, that is A to D direct path. It is having the distance as a 7 here. And one more path is there, that is A to B and B to D. So now if I select this path, what is the path the distance now? That is the 3 plus 2, 5. So among these two, which one is shortest now? 5 is shortest or 7 is shortest? 5 is shortest. So now from A to D, shortest path is 3 plus 2, that is 5. That is A to B and B to D. In the same way, now source is A and our destination is S. Now I have to find the path from A to C here. So now for that also I have the two paths. Now A to B and B to C, one path. That is saying the distance is what? 3 plus 4, it is 7. One more path is there, that is A to D and D to C. That is saying the distance is what it is? 7 plus 5, it is 12. So one more is there, that is A to B, B to D and D to C. That distance is 10 here. So now among these three paths, I have to select which path? Which path is the minimum now? Among 10 and 12, so which one is minimum? A to B and B to C is the minimum, that is the distance is 7. So that is from A to C, length is or path length is 7 here. 3 plus 4, it is 7. In the same way, now I have to find the shortest path from source A to destination is what now? It is E. From A to E, now I have to find the path now. So once again you are having the so many paths here. One path is A to B, B to C, C to E, and one more is A to D, D to E. So among all possible paths you have to select the which path? That path is having the minimum length. Now for example, if I select A to B, B to D and D to E, this path is having the shortest path now, that is 3 plus 2 plus 4, it is 9. 3 plus 2 plus 4 is 9. It is actually what actually single source shortest path means. Is it clear now? From source A to remaining all the vertices, you have to find the path, and that path distance must be shortest. So now to get the solution, now in general so many paths are available. Among those paths I have to select which one is minimum. So but in the, as I told you, in the greedy method, it is not necessary to find the all possible solution. Only one solution you have to find. So that solutions now you are getting using which algorithm? That is the Dijkstra's algorithm. Next, let's see what is the principle of Dijkstra's algorithm. I'll take the same example and I'll find the solution now. Shortest path problem solution using Dijkstra's algorithm. See, to get the solution, so using Dijkstra principle, how it works? First, once again, you have to make as a 3 columns, and each column captions are what now? First column caption is tree vertices. Next one is remaining vertices, and next one is the illustration. Are you heard the same thing in somewhere? Yes, in the Prim's algorithm you are used the same concept. It is same as Prim's algorithm. Only difference is what? Here you are finding the distance from source. There you are directly writing the adjacent vertex with the minimum. Okay, but here you have to find the distance from source. That is the only difference. Otherwise, Prim's algorithm and this Dijkstra's algorithm both are same, but procedure is same, but problem is different and getting solution is also different, because in the Prim's algorithm you have to find the minimum spanning tree, whereas in Dijkstra's algorithm you have to find the shortest path from source to destination. Now assume that this is the graph, and one more thing, source may be anything. So in the examination you may get the question is what? Consider C as a source vertex. From source vertex to remaining all other vertices you have to find the shortest path. Or they may give the example question as a consider B as a source vertex. From B vertex to remaining all other vertices you have to find the shortest path. So which is your source vertex? That source vertex first you have to write. In the first iteration you have to write your source vertex. But now at present I am taking the A as a source vertex. So now if A is the source vertex, my aim is what now? I have to find the solution, that is the shortest path from A to B, A to D and A to C and A to E here. Let's see how we'll get that solution. So this is the source vertex. As you know that if it is A, and this indicates what? Vertex name. And next inside the bracket, first value it indicates what? Adjacent vertex and weight of the adjacent vertex. At present A is your source vertex, that's why it is dash, and this is the source vertex, that's why you are taking as a 0. During in the first step, in the first iteration, you are taking one initialization, that is actually here source vertex is 0 and remaining all the vertices are initialized with the infinity. I don't know what is the distance, that's why earlier all these vertices are initialized with the infinity. For the A, distance is 0. For the B at present it is infinity. For the D it is infinity. E also infinity and C is also infinity. So this is the initialization. So now A dash, and what is the distance now? It is 0. That's why A dash 0. Next in the second column you have to list the all the remaining vertices. What are remaining vertices? B, C, D, E. See, B, C, D, E. Next, what is the next step? You have to check from source. Now you have to concentrate on source. From source to that vertices you have to check the path here. So now from A to B is direct path is there. So now if direct path is there, then you write that A here, and what is the distance now? 3 is the distance here. That's why here you are written as A comma 3 here. Next C. Is there any direct path from A to C? See, from A to C there is no direct path here. That's why you have to take as a dash. And what is the distance of the C now? It is infinity. You already initialized as what? Infinity. Next D. Now A to D direct path is there. Okay, so that's why here you have to take as what? A. And what is the distance now here? It is the 7. Whenever you visit now, this infinity is changed with the distance value as a 3 and 7. That's why you are taken as a 7 here. Next E. Is there any direct path from A to E? No, there is no direct path. That's why you have to take as a dash and infinity. So this is your first step. So now in the first step, first you have to take a source vertex and the remaining vertices you have to take here, and if it is adjacent, that is direct path, if it is there, that path and name of the vertex you have to write now. So that is the first step. After listing, same procedure. So now you have to check the edge weight of the all the edges of the vertex. So now this is the 3 and this is infinity and this is 7 and this is infinity. So after selecting that, what is the next step? Among all these edge weights, which one is having the minimum, that one you have to select next. So 3, as I told earlier, infinity means what? Very big, very large value, and 7. So 3 is the minimum. So now I'll select this path now. A to B, it is selected. A value, A distance is 0 because it is source. Now from A to B it is 3 here. So which path you are selected now? A to B here. Which path you are selected? That path you have to write here, and it is final. Now from A, source A to B, you already got the solution. That is the shortest path is 3 now. Now next our aim is what? We have to find the shortest path from A to D and A to C and A to E. For that, once again you have to list all those remaining vertices in the second column. Remaining vertices are what now? C, D, E. At present all these weights are what? Infinities. C, D, E. Now same procedure, this, okay, all these vertices you have to list, and only thing is what it is. Now see, from A to C there is no direct path, but you already visited one more vertex, that is B. From B to C you are having the path here, direct path, that is the adjacent. C is now adjacent to B here. So that's why here that adjacent vertex is you are taken as a 3 here. So and now distance is what now? Distance is, earlier in the Prim's algorithm you are writing only 4 here, but here you have to find the shortest path from source. Which one is your source now? A is your source. That's why, so yes, it is adjacent to B. With the help of B, you can get the path from A to C. Now it is possible to move from A to C with the help of B here. That is A to B and B to C. So now, but path distance you have to calculate from where? From source. That's why you have to take it as what? 3 plus 4 it is. A to B it is 3 and B to C it is 4. That's why it is what? 3 plus 4 here. Next same thing D. Now this D vertex is what? It is adjacent to B and also it is adjacent to A. If it is adjacent to more than one visited vertex, then which one you have to select now? So you have to select which edge weight is minimum. Among these two, 7 and 2, which one is minimum? 2 is the minimum here. As I told earlier, it works as a same as a Prim's algorithm, but only path calculation distance you have to consider from source here. So now you are selecting the which one is adjacent to D now. B is adjacent to D. Earlier you have taken A as adjacent because at that time you are not visited B. That's why you don't know this path. Okay. Now after visiting B you get to know that there is the one more path from B to D here. And that distance is what it is? 2 here. Which one is minimum here? But here path you have to calculate from what? A to D only. So A to D means what? You have to calculate the path distance from source to D here. That is A to D. That is what? A to B and B to D here. So now A to B it is 3 and B to D it is 2. Means what? Total distance from A to D. If you want to reach D, then you are not going directly because you are having the distance is 7. Which one is not a shortest one? If you take this path, you will get the minimum distance. That's why you select this path here. 3 plus 2 is the minimum. Next, same thing, E. Is it adjacent to B? No. Is it adjacent to A? No. That's why, what is the thing you have to do now? You leave this one as a dash and infinity. After checking all the vertices, next step is what? You have to check which one is having the minimum edge weight. This is 3 plus 4 and this one is 3 plus 2 and this is the infinity. So 7, 5 and infinity. Which one is minimum now? 3 plus 2, 5 is the minimum. So that's why I'll select this vertex to this part to visit D. Now this path is already fixed. Now I am getting the A to D also path is fixed. That is the B comma 5 here. Why I am taking B here? Because I am reaching this D with the help of this node here. That's why it is what? D, B comma 5, B comma 5 it is. So now we have to list the remaining vertices. So what are the remaining vertices now? C and E here. C and E are left as a unvisited. C and E, same thing. So now the C is what? It is adjacent to B and also it is adjacent to D here. So if it is, both are already you are visited. You already selected in the first column means what? You already visited. So you may have the question that, so now here I am the 4 and here you are in the 5. Among 4 and 5, which one is minimum now? So 4 is the minimum. So that's why you have to select the which path now? 4 as the path to visit here. As I told earlier, for any vertex, if you get the more than one vertices, visited vertices, okay, then you have to select the which vertex edge weight is minimum, that one you have to select. 4 is the minimum. That's why I selected the this path here. But one thing you remember, as I told earlier, your distance you have to calculate from where? From A you have to calculate here. But from A to C, direct path is not there, but with the help of the B, you are getting that path. So that's why it is what? 3 plus 4, it is 7. Directly, okay, here they are taken. Next, now E. So now E. So now this E is what? So now E is the adjacent to D. See, D already you are visited. So now you have to take the E. E is adjacent to D here. What is the path distance now? So one thing you remember, you already selected one path from A to D. It is fixed. That is the A to B and B to D. What is that distance? 5. 5 plus 4, it is what? It is the 9 now. Okay, one more path is there, 7 and 4, but already you got the solution that A to D, 5 is the shortest distance. That's why you are listed here. So now that's why D equal to 5 plus D comma 5 plus 4 is. So among these two, which one is minimum? Once again, 7 is the minimum. So this is the next path you got as a solution, that is A to B and B to C. Now you got the path from A to C with the minimum distance as a 7. That one you listed here. Next, only one vertex is left, that is E. So now for the E, you are having the so many paths here. Either you can move from A to B, B to D, D to means what? E now it is adjacent to C and also it is adjacent to D now. Because thing is what? C is already you are visited as it is here and E also you already visited as it is there in the first column. If it is in the first column, meaning of that one is what? Those vertices are already visited. So now your aim is what? You have to select which one is having the minimum distance here. 6, 4, which one is minimum now? So this 4 is the minimum. That's why you are taken as a D here. But here you are not writing 4 here because thing is what? You have to find the path from source A here. That's why A to B and B to D path already selected. That is, and the distance is what? 5. 5 plus 4, it is what? 9 now. So this is the only one vertex is left, that one I selected. So now after completion of this step, let's see what are the path you got. That is what is the distance. From now A is source and B is the destination. Path weight is what? It is 3. And A to C 7 and A to D it is 5 and A to A it is the 9 here. This is the solution what you got and that one you got in the first column. In this way, Dijkstra's algorithm works here. Is it clear? So, it is same as Prim's algorithm. Only thing is what? You have to consider the path distance from source A, not from the direct edge weight. Okay, in the Prim's algorithm, which one is adjacent? That edge weight only you are considering. But here you have to consider from the source. That is the only difference here. Otherwise, it is same as the Prim's algorithm only. So, in this way, you will get the solution for the problem. So, here I taken source as A. From A to remaining all the vertices, I got the solution here. Source is A only. And all these vertices are destination. That's why you are using the word as what here? Single source shortest path. Is it clear now? Okay, let's see how actually it works. Okay, So now in general I already explained. Now we'll see the algorithm. Algorithm, as I told, if you want to write the any algorithm, first you have to write the notation as algorithm, Dijkstra's algorithm name, graph G. So here which type of the graph you require, because shortest path if you want, then it must be weighted and it must be connected graph. And with one more condition is here, it works for only non-negative weights. Means what? Weighted graph that must be contain only positive weights here. Okay, if graph contains positive weights, so then this Dijkstra's algorithm works to find the single source shortest path here. Output is what? You are using one notation here, dv. dv is the length, distance. So here what actually dv means, what it is? It is the shortest path from source to v here. Now for example, if I take as a db, means what it is? It is the shortest path from source A to B. If I take a source as A, so A to B, what is distance? That is the 3 here. Okay, so now here dv means what it is? Same thing. S is your source and this one is your vertex. What is the distance from S to V? That distance only you are representing in the form of dv here. And you are using one more thing, that is the penultimate vertex. Penultimate vertex, that one you are representing as a PV, that is last but one vertex. So for example, now I already visited, okay, A and B. Now I want to visit this vertex. After visiting this vertex, this is your last vertex. Then which one is your penultimate vertex? B is your penultimate vertex. PV means what it is? If C is your last vertex, then B is your penultimate vertex. Last but one vertex here. And you are using one more notation, that is the V. V is the set of vertices. For example, in this graph, how many vertex you are having? A, B, D, C, E. All this vertex set you are representing as a V here. Okay. So now first step is what? You have to initialize Q. So now in general I explained that thing. Same thing if you want to represent that columns, all those things you have to show, no. So to represent this procedure, you require to store those values, all those vertices, and where you have to store. For that purpose you are using a queue here. That queue is the priority queue. Priority queue means, as you know, that with the values for the queue elements you are having. At present you are using as a empty. Now queue is empty. Next, for every vertex v in V. Small v means what? It may be any vertex among the set. So now v means what it is? Set of vertices A, B, C, D, E, F. So if I take as a is what it is? It is small v. So now A is a first vertex and dv equal to infinity. dv means what? Which vertex I taken v now? dA equal to infinity. So now this is the thing. First you have to take as a dv as a infinity and pv equal to null here. Because this is the first vertex, I don't know which one is the last but vertex. Because this is the only one vertex, that's why I taken as a null here. And insert in q. Q, now earlier q is what now? Earlier your q is empty. Sorry, earlier your q is empty. Now I am initializing with the q with the first vertex, that is which vertex? I assume that A is the, I'll take this example and based on this example only I'll explain. A is your first, okay, vertex and dv. dv means what it is? Distance of the A. So now distance of the A, during first step I initialized all the vertices are initialized as a infinity. That's why it is the infinity. This is your first element. Okay. Next thing is same thing you are using. This one is alignment is chain means what? These two statements comes under this for loop and you are repeating this for the all the vertex. So first one is A, next is B and B also with the infinity and same thing C dash 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 up to E infinity. You will store the values. Now your priority queue okay contains the all the vertices with the distance as a infinity. Next step, I'll take the ds. Ds means what? Source. Any vertex you can take as a source. I'll take first now as a dA as a source, and that one I'll initialize as a 0 and decrease q as ds. So now in the q, you update the this value. Earlier for the a, dA is the infinity. Now what it is? It becomes 0. Decrease q of s comma ds means what? Source vertex. I taken a as a source vertex, and what is the distance now? Distance of the source vertex I initialized as a 0. That's why you update this vertex as a 0 now. Okay, next I am taking one more vt as a variable. It contains the set of vertices. At present I don't have any vertex, that's why it is I'm taken as a null here. Next I'll do the for I equal to 0 to v minus 1. V is what? Set of all these vertices, but I initialize with the 0 means what? First vertex I'll consider as a 0, 1, 2, 3, 4 here, because I can't take as a 1, 2, 3, 4, okay, A, B, C, D here. That's why I'll take the node's name as a 0, 1, 2, 3, 4 here. So actually how many vertices you are having? 5 vertices you are having. But what is your, if you are initialized with the 0, 1, 2, 3, last vertex is 4 here. That is the thing. 0 to 4 you have to consider here. Next, U star here. So U star means what it is? Let's see. So what actually it contains? Delete min queue here. Delete the minimum priority element. See here in the priority queue, A, B, C, D, all the elements are there. But what is the priority of all the elements? That is infinity. Only one element value you are changed as a 0 here. Which element? That is the A here. So infinity means what? It is very large value. So among all infinities, 0 is the minimum. That value I'll remove now. After removing that, now U star becomes what now it is? U star is now it is the A. Okay. So now that VT. So VT is the solution vertex set. Okay, so this solution means what? T means what? Traverse. Traverse means what it is? However you're going to visit the vertices, which vertex you are visited and what is the solution you got, that solution will store in a one set. So that's why you're taking this one as a VT. And now in the VT you are adding what? I'll write here, because VT equal to what? This is the first vertex as a source, and I'll add up this one here. Union means what? You are adding that element to now. This is the first step you are done here. Okay. A equal to dash 0. So this is actually your VT. Okay. VT means what? Set of vertices. Set of vertices which you got as a solution. So now here first vertex, now at present you have taken as a 0 here. Same thing. 0, that distance you have taken already, you are initialized as a 0, and that vertex only you are visited first. Next one is for every vertex u in v minus vt. So v contains what? A, B, C, D, E. So now v is the set of all the vertices. So now v minus vt. Which vertex you are visited now? A. Means what? You have to don't consider this vertex. Okay, remaining all the vertices you can take as a U now. That is adjacent to U star. U star is what it is? A. Now you don't consider this A, and for this A, what are adjacent vertices you are having, that one you have to consider. So now I'll take the, so A, for A what are adjacent vertices? B and D now. Okay, at present for A, B and D are adjacent. So now I'll take as a B first. Okay, at present I'll take as B. Next is if D U star here, distance of that particular vertex. So now what is the distance now? D U star means what? Which vertex? A. And what is the distance of that one? That is 0. So now here only I'll write that 0 plus W of U star comma U. U star is your vertex which already it is there in your VT, and U is adjacent to U star. Now A is your vertex as a U star, adjacent to A is what it is? B here. So what is the weight? W means what it is? Weight of the edge which connects your U star and U. That is edge which connects your A and B, and what is the weight of that one? What is weight? It is 3 here. Okay, one step I forget. Here I have to write, no, sorry, 0 plus 3 here. Okay, and du. Du means what? B. What you are initialized as a weight now? For that one as a infinity. So as I told earlier, infinity means very large value. So now 0 plus 3 means what? 3. 3 is less than infinity. S, if condition is true, then you have to modify your du value. Du means what it is? B. And now you have to change this infinity as a what? 3 here. Okay, this one you already removed, and now you are updating this value in the Q here. So next Pu equal to U star here. So now at present only one vertex, because this is the vertex you are visiting now. So last but one means what it is? Penultimate vertex means what? Last vertex but one. That is A here. Now Pu is what? A it is. Okay. So next is decrease Q of U comma du. That is the thing already done here. B becomes now 3 it is. Next, for every vertex, because for A you are having the two vertices, B and D are the adjacent. So now B it is over. Now I have to take the U as a D now. Same procedure, 0 plus U star U. U star means what it is? A, and D means what it is? U means what it is? This is your U star, and this is your U now. So now you have to find the weight of this weight. Okay, which weight which connects U and U star, and what is weight that? So now weight becomes what it is? 7. So earlier D you are initialized as a infinity. Now you are changing that one also. What now? 7 here. D of dash 7. Earlier it is infinity. Now you are changed as a 7 here. Okay, obviously 7 is less than the infinity. That's why you are taken as a, you are modified that value, and you are updated value also you are updated in the Q here. And same thing, obviously this is the last but one vertex. That's why A is the your penultimate vertex here. So after that, is there any vertex left as adjacent to A? No, it is not adjacent to A. Then you come out of this particular for loop. Whenever you come out of this for loop, your work is here. What is that? 0 it is over. Next you are considering as a 1 here. So now in the next step, 1, delete min with the Q. So in the priority queue, now you have to check the minimum values here. So what is the minimum values? 1, you are modified B with the priority as a 3 and D with the infinity. Remaining, sorry, 7. Remaining all are infinity here. Among 3 and 7, which one is minimum? 3 is the minimum here. So now you have to take U star as what now here? I'll rub it. So, sorry, I'll rub it here. VT, I'll keep that one only. One vertex you already visited. Okay, A it is there. So now you are going to take this as a U star here, because U star B is having the minimum value here. And this one you are adding to your vertex VT solution. That is the next step you are done. In the first iteration, this is the step. Next in the second iteration, see B of A comma 3. Same procedure you are done there. Same thing, only you are okay showing in the form of the Q now. Okay, same thing. Now for the B adjacent vertices you have to check. For the B adjacent vertices are what now? This one is U and this one is U. In the first iteration you can take C as a U. In the next iteration you can take D as a U. Next, if D U star. So now what is the distance of U star now? U star it is what? Distance. It is already you are taken selected, and that is 3 here plus, and this 3, okay, it is there. Now C is adjacent, so now U star to U, it is connected with the edge weight as a 4 here. That is 3 plus 4, 7. 7 is less than the infinity. Now this one is your infinity and this is also infinity. In your priority queue, these values are stored in the form of infinity. Now it is modified as a 0 and this one is modified as a G. Okay, so now this is the thing, infinity. 3 plus 4, it is 7. As I told, it is less than the infinity. So now you have to modify the du value as a 7 here. In the place of infinity, now you have to take this one as a 7 here. And for this one, you have to take as a u star. Now u star is what? B. So now earlier pu you already taken as a penultimate vertex as a. Now last but one vertex. Now it is what? B here. C is your last vertex. Last but one means what it is? B is the last but one vertex here. So now B you are assigning here and you are modified the weight here. Next D, same thing you'll see. And now it is, what is the distance you'll get now? 3 it is there. 3 plus 2 it is becomes what? 5. Okay. So 3 plus 5, it is the same procedure. 3 plus, it is 2 now. And 5 is less than infinity. Yes, then you add that one also as a last but one. Sorry, it is fixed. You reduce that thing. So now you are modified the weights now. So now in the priority queue, you are updated the D distance value as a 5 and C distance value as a 3 now. In the priority queue, okay. In the priority queue, D you are modified as what? 4 and sorry C C as a 7 and D as a 5 here. Is there any vertexes adjacent? No. Then you will comes out of this for loop. Then you will go to this one. So now once again you have to consider the remaining vertices here. AB it is already there. Remaining vertices are what? C, D, E here. Next you delete the min. So which one is min now? 7, 5 and remaining E is the infinity. Which one is minimum? 5 is the minimum now here. Okay. D is the minimum. Okay. That one you have to take what now? Okay. So in the next step, A it is already there and B is also there. Now you are going to take as a D and you are in taking D here. Sorry, D here. So in the VT, A already visited, B also visited. Now you are added D also, and now you are taking what? This one as a U star, and adjacent for this one is C as a U, and this one as a U, and this weight it is already, it is 3 and this is 0 and this is 5. Okay, so now same procedure you have to repeat now. 5 plus 5 is 10, 3 plus 4 if you take, it is in the minimum distance. That's why I'll take as a 7 only. Here I'll explain that thing. Okay, how actually it works. See, so now U star is what it is? D now. Okay, for every V, I'll take C as it is. So now D of U star value. So what is D of U star value now? D of U star value, it is the 5 here. And plus, what is the weight it is connects? 5 plus 5 it is 10. What is your du value? You already modified that value and it is 7 now. So now 5 plus 5 means what? 10. Is it less than 7? No. If condition fails, then you are not modifying this value. You will take this value as it is. You are not executing the steps now. Condition fails here. Simply you will move to the E. And for the E, earlier it is infinity. That's why you can take this one as a 5 plus 4 as a 9. 9 will be modified here in your priority queue. Now C value is 7 and E value it is modified. In the place of infinity, it is modified as a 9 now. Okay. Next, among these two, which one is minimum? 7 is the minimum and you'll take that 7 and you'll repeat the procedure. Same thing you will repeat for up to E only. In this way, you will get the all those vertices in the VT. See, same thing you are done here also. So now in the VT, first vertex is A, B, next D, next C and E. Here also what it is? A, B, D, C, E. Yes, in this way, how actually this particular algorithm works. Is it clear? Okay. Next. So now correctness can be proven by induction on the number of vertices. You have to prove that whether it works correctly or not by using the induction method. So and one more thing you have to remember here, Dijkstra's algorithm, okay, Dijkstra's algorithm, it works for only positive work. Okay, only positive weights, if it is there it works. That is non-negative means positive only, it does not work for the negative okay weights here. And efficiency, so for this one, as you know that if it is the graph, that graph you can represent using the adjacency matrix or you can use the list here. Okay, so if you are using the adjacency matrix, then you are taking as a rows and columns. Rows and columns, it is what? V square. So if you are using the adjacency list, then you are taking as a edges and weights. In that time you are taking the weight as a big O of E log B. Okay, if you are represented in the form of the array, means what it is? Array is rows and columns. That's why n into n square. Here n means what? Number of vertices. That's why it is the V square. If it is adjacent list, then you are taking as a nodes. Okay, each node you are connected in the form of the edges. Vertices are nodes and each node you are connected with the help of the edges. In that time you are taking as a big O of E log B. Okay, this is about your Dijkstra's algorithm. Thank you.